Principle 6 is about keeping the application tier stateless. We think you should preserve all your app state in external persistent stores using as few stores as possible. Ideally, you just use one store. Now, what's an app state? There's all sorts of states associated with an app. Some examples of application state are user session state, the page a user was on, shopping cart, etc. There's also user preferences or the position of the app in a multi-step workflow, the configuration for deployments, runtime configurations, etc. So keeping all of the state external to the application makes the app resilient to failures in the layers below it. So you enable quicker recoverability. You also have the benefit of application state having the same security guardrails as application data. So take encryption. Just like you encrypt your application data, you can encrypt app state as well. One important consideration here is you don't want the data scattered across multiple stores and then run the risk of this data getting out of sync after failures. That's why we say that as far as possible, use just one external store. And we recommend that if you're already using Oracle Autonomous Database for application data, use it to store application state as well. Because Autonomous Database supports multiple formats and types, this keeps things more consistent than using multiple single-purpose stores. If the app does not use a database, then there are other choices, durable persistent stores like OCI Object Storage Service, for instance. Let's move to Principle 7. Use converged databases with full-featured support across all data. Now, what's a converged database? A converged, and sometimes it's referred to as a multi-model database. This is something that supports natively different types of data, whether it's JSON data, relational data, graph, spatial data, etc. When you leverage a converged database, a developer can do something like store a new JSON document, insert a relational row, and update a property graph, all within the same asset transaction. They can then use SQL to query, join, filter, and aggregate across all of these types. So they can get the same types of guarantees that they're used to in a relational world. Now, obviously, a big advantage of this approach is reusability. Developers don't have to learn a separate database technology and tune things for various data types, etc. Oracle recommends using Oracle Autonomous Database to deliver on this design principle. You can also simplify the maintenance using views to expose the data in the tables. So you can change the underlying schema and you don't affect existing apps. You should also look to leverage related capabilities like Oracle Data Save to evaluate and implement security controls. You should use edition-based redefinition to upgrade your apps without downtime. And you should use Oracle Data Guard for HA and for disaster recovery. Okay, so the principles we've talked about so far have covered considerations in each of the individual sort of development, deployment, and runtime areas in the app lifecycle. The next three principles really apply holistically across the entirety of the app lifecycle. So let's talk about Principle 8, Instrument End-to-End Monitoring and Tracing. As developers build modern apps, failures happen in newer and more unpredictable ways than they might have been familiar with in the monolithic model. So there are so many new types of interactions between the app's components as well. The infrastructure is elastic, so that adds to more failure modes. So it's really critical for developers to maintain an authoritative and timely view of the application's health, the application's performance, the operational state, and any security incidents related to the application. So this will help them make sure that the key expectations on each of these dimensions is being met. And if they're not, that they're able to take action immediately to remedy that situation. The only way you can do this is by instrumenting the app and the infrastructure through the entire life cycle. So our technology recommendations comprise a broad set of fully managed services covering all aspects of this lifecycle. OCI logging provides a single pane of glass covering infrastructure and application level logs. OCI monitoring provides metrics and alarms that can be used to monitor resources both actively and passively. Log analytics gives you deep analytics capabilities into log data that's spanning application and infrastructure data. APM gives you deep visibility into the performance of your application. And finally, if your application uses Java, we recently launched the Java Management Service. So this enables you to monitor and manage your Java runtimes. And it's doing this by using telemetry data that's sent from the JVM. Principle 9. This is about eliminating single points of failure through automated replication and disaster recovery. So modern hardware is great, right? It's gotten a lot more reliable. But despite that, everything fails, right? Machines, networks, disks, they're all going to fail at some point. In fact, entire data centers may become unavailable because of natural disasters, think fire, hurricanes, earthquakes, etc. So for high availability of your app, the data on which it relies must be available in the face of this failure. Replication of your data is key to this. Our technology recommendations here involve the use of Oracle Autonomous Database, DataGuard, and Golden Gate for all of your high availability database use cases. So between these, you get active-active replication setup and cross-region replication. Now, Oracle Cloud Storage Services for block or file or object storage give you replication across availability and fault domains. And this helps you protect data in the event of machine, network, or data center outages. For disaster scenarios that affect entire regions, Golden Gate, as well as specific features in object storage and block volumes, give you cross-region replication. So you're really covered across each of these failure types. And now finally, Principle 10, implement a defense in depth approach to secure the app lifecycle. Security is the most foundational requirement for modern apps. So we really need to apply it across every aspect of the app lifecycle and at multiple layers. It's also really important for developers of the app to be able to add security controls simply, and they shouldn't have to become a security expert to be able to do this. And finally, security considerations need to include thinking about, it's not just about preventative mechanisms, but also detective mechanisms, and then remediation for issues that have been detected. Oracle's technology recommendations span a wide swath of security services to deliver on this design principle because we are trying to protect the entirety of the app lifecycle. Web application firewall limits traffic from unknown locations, Tor nodes, etc. VCN security groups enforce the minimum reachability principle and provide endpoint isolation. Oracle Security Zone service gives you a way that you can create compartments for your infrastructure resources that are secure by default. So any apps that are launched in these compartments automatically leverage this protection. It's a great example of a preventative mechanism. OCI Identity and Access Management gives you strong authentication and security policies for access control. CloudGuard provides the ability for you to monitor for misconfigurations or anomalous activity. So that's an example of a detection mechanism. Another example is the vulnerability scanning service. So this service periodically scans virtual machines and containers for vulnerabilities from the CVE database. So we've covered a